All right, this is a screencast on solving and graphing exponential practice. You already know how to solve and graph exponentials. So the first part starts with a warm-up. So go ahead, pause the video, try that, and then I'll do the four properties of exponents problems because they are more challenging, much more challenging than the ones that we did in the previous screencast, and then the rest of the graphing will be for you to practice. All right, let's see how you did. On the warm-up, here is the first two. What might have caught you up on the first one is that this is 1050, not 1150. It's almost hitting that 11, almost looks like it's hitting 11, going past the naked eye. All right, and here is the last one. I don't care how you rounded B, if you did 3 decimals or a whole number. We can argue all day about that. Okay, so this is all no calculator here. This would be on the no calculator portion of your test, unlike number 3 here, which would be on the calculator portion. This says use properties of exponents to solve. Okay, so we have this problem right here. So I have to think about solving this without a calculator. All right, so I have to think of how I can do this. I have to know how I can rewrite them to have the same base. So I know 2, 4, and 8 can all be rewritten as a base of 2, so that's where my brain's going. And so I say, okay, then I can rewrite 256 as a base of 2 also. So I'm going to rewrite everything as a base of 2. 2 is already written as a base of 2. That's 2 to the x. 4 is 2 squared to the x. And then 8 is 2 cubed to the x power. So then we can use properties of exponents to do power to a power on the second 2. So that's 2 to the x times 2 to the 2x times 2 to the 3x, right, is equal to 2. I'll fill in the blank here in a second. Okay, I'm not going to just leave that there. Or I can put 256 if I went over there. Actually, let's start thinking about that now. 2 to what power gives me 256? So I know 2 to the 5th power is 32. 2 to the 6th power is 64. 2 to the 7th power is 128. So 2 to the 8th, oops, that looks like 28. 2 to the 8th power is 256. There's my brain thinking. This is 8th power, okay? And I'm gonna erase my brain thinking right here because I don't need it. All right, so now I'm at this point. I have my next property that I'm going to use is that if I have the same base of where I'm having things being multiplied, I can keep the base and I can add my exponents. So x plus 2x plus 3x is 6x is equal to 2 to the 8th. And then now I can keep my base, or since the bases are the same, I can say that the exponents have to be equal to each other. All right, so I have 6x is equal to 8. Divide by 6, and I have x is equal to 4/3. Little puzzles here, huh? Okay, let's move on to the next one here. All right, so the left-hand side has a base of 5. The right-hand side has a base of 0.04. So I can see that that's a decimal. Writing as a fraction is going to make my life easier. 5 can't be written as any other base, so I know that that's going to be left alone. And then this, how you say it out loud, is 4/100ths, right? So this is 4/100ths to x plus 3. And then I can simplify that fraction, right? Which I could have just done that right away, but hey, it's 1/25th. There we go, right? To the 2x minus 3. And then I know 125 is 5 squared, and then I can rewrite that as 1/5 squared, which is 5 to the negative 2nd power. So 5x minus 1 is equal to 1/5 squared, which you could skip that step if you want. 5 to the x minus 1 is equal to 5 to the negative 2nd power, the 2x minus 3. So now we have a power to a power, so we can keep our base and multiply our exponents. 5 to the negative 4x plus 6, and then now I have the same base, so I can set my exponents equal to each other. So we have x minus 1 is equal to negative 4x plus 6, Add 4x to both sides, that's 5x. Subtract 1 from both, or sorry, add 1 to both sides, that's 7. Divide by 5, and we get x equals 7/5. Did I write something down wrong? Oh, that was a -6? No, it's not. Is it a positive? It was a +3. Okay. +3, +3. Let's go back and fix this. -6, -6. It's not 7/5. So where did I make a mistake? All right, so distribute your -2, that's -4x minus 6. Set your exponents equal to each other. And now add 4x to both sides, add 6 to both sides, or add 1 to both sides, we have -5. Divide by 5, we have x equals -1. Okay. Here we go. All right, if that was a -3, then my other answer would have been fine. Okay, not that there was anything wrong with that answer. All right, here's the next one. So on this one, if you look at the left-hand side, it has a base of 2. There's 2 equations. So I'm going to have to make 2 equations, and there's 2 variables. So this is going to end up with a system. That's thinking a little bit ahead here. Base here is 2, which is as low as it can go. Base here is 8, which I can rewrite as 2 cubed. So I'll do that. 2 to the x plus y is equal to 2 cubed. So there's an equation I can make from that. X plus y is equal to 3. Right? My exponents have to be equal to each other. And then this one is a 1 right here, so it's already ready to go. Right? X minus y is equal to 1. So that's a system. We know how to solve a system. You can use substitution or elimination. I would use elimination on this one. So I'm going to add these 2 together. And we have 2x. Y and -y cancel, equals 4. Divide by 2, x equals 2. And then to solve for y, we can plug it back into either one. So I'm going to do 2 plus y equals 3, y equals 1. So x equals 2 and y equals 1. Okay, this is a point of intersection, so you could also write it as an ordered pair. Which I would probably prefer because that's the directions say solve for x comma y. So we should say 2 comma 1 is our answer instead of boxing that. Okay. All right, let's move on to the next one. So the next one, I can see the left-hand side has a base of 3. The right-hand side has a base of 27, but I can change it to 3 cubed. So I will start by using my property that says if you have a base divided by a base and it's the same base, you can keep the base and subtract your exponents. 3 to the x minus y is equal to 3 cubed. And then left-hand side, base of 2, base of 4, which I can rewrite the 4 as a base of 2. So that is 2 to the x times 2 squared is equal to, and then 16 is 2 to the 4th. And then I have the same base with multiplication, so keep your base and add your exponents. And now I can make an equation from this and make an equation from this. So we have x minus, oh, I lost my, it's not a 2. This is not a 2. Oh, I lost my y, I should say. This is 2. And then I lost my y right there. My bad. This is 2y. Okay, so I can make my equation now. X minus y equals 3. I felt like it was too easy when I was writing x plus 2 equals 4. It's x plus 2y is equal to 4. Okay, so I'm going to use elimination again. I'm going to multiply the first equation by 2. That becomes 2x minus 2y equals 6. It's not the only way to do it. And I have 3x is equal to 10. Divide by 3, and I get x is 10/3. Not beautiful, but whatever. And then now I still need y. So I can go back to either equation. I'm going to use the first one. So I'm going to do 10/3 minus y is equal to 3. So I'm going to subtract 10/3 from both sides. Minus 10/3 minus 10/3. We have negative y is equal to, rewriting 3 as 3 over 1, multiplying by 3, that's 9/3. So 9/3 minus 10/3 is negative 1/3. And dividing by -1, we have y equals positive 1/3. So this solution is 10/3, comma, 1/3. Okay, that's it for the more challenging problems. The rest of this is all graphing, so you can either pause the video or stop the video. Check your answers on Schoology on the answer key, or you can check your answers on this video by pressing play. So here's the first two. You can pause it if you need to. Here's the second two. You can pause it if you need to. And here's the last two. You can pause it if you need to. All right, that's it.